ceiling grid that is not riveted to side angle support should not be used as the primary means of support for lay and fixtures. The primary reason for this is structural integrity and safety. Ceiling grids are typically designed to support the weight of the ceiling tiles themselves and light incidental loads. They are not engineered to bear the additional weight of electrical fixtures, especially over extended periods. Using the grid as the primary support can lead to several issues. Firstly, the grid may sag or deform under the weight of the fixtures, which can create an uneven and unsightly ceiling. Secondly, and more importantly, it can create a safety hazard. If the grid fails, the fixtures could fall, posing a risk of injury to people below and damage to property. Thirdly, electrical connections within the fixture could be strained, leading to loose wiring, arcing, and potential fire hazards. The National Electrical Code, or NEC, addresses the proper supportive electrical equipment, including lighting fixtures. The NEC mandates that fixtures be securely supported by approved means. This typically involves using independent support wires, chains, or other listed hardware that is attached directly to the building structure above the ceiling. These support methods are designed to carry the weight of the fixture safely and reliably. When installing lay-in fixtures, it is crucial to use these approved support methods in addition to the ceiling grid. The grid can provide some secondary support, but it should not be the primary load-bearing element. Here are some best practices for supporting lay-in fixtures. 1. Always refer to the manufacturer's instructions for the specific fixture being installed. The instructions will provide guidance and the recommended support methods and hardware. 2. Use independent support wires or chains to attach the fixture to the building structure above the ceiling. These supports should be capable of supporting at least 5 times the weight of the fixture. 3. Ensure that the support wires or chains are securely attached to both the fixture and the building structure. Use appropriate hardware, such as eye-bolts or beam clamps, to make the connections. 4. If the ceiling grid is being used for any secondary support, make sure that it is properly installed and in good condition. The grid should be securely attached to the side angle supports and free from any signs of damage or corrosion. 5. Inspect the installation regularly to ensure that the fixtures are securely supported and that there are no signs of sagging or deformation of the ceiling grid. 6. For heavier fixtures, consider using additional support methods such as trapeze hangers or unistrut channels. These can provide a more robust and reliable support system. 7. Always comply with all applicable electrical codes and building codes. These codes are designed to ensure the safety and proper installation of electrical equipment. 8. When working with electrical fixtures, always disconnect the power supply before beginning any work. This will help to prevent electrical shock. 9. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to perform the installation. They will have the knowledge and experience to ensure that the fixtures are properly supported and safely installed. 10. Consider the seismic requirements in areas prone to earthquakes. Additional bracing and support may be required to prevent fixtures from falling during seismic activity. The NEC provides specific requirements for seismic bracing of electrical equipment. 11. Use listed or labeled products for all support hardware. Listed products have been tested and certified by a recognized testing laboratory to meet safety standards. 12. Avoid overloading the ceiling grid with excessive weight. Distribute the weight of the fixtures evenly across the grid to prevent sagging or deformation. 13. Never rely solely on the ceiling grid clips or tabs to support the weight of the fixture. These clips are typically designed for alignment and secondary support, not for primary load bearing. 14. Ensure that the support wires or chains are not in contact with any sharp edges or abrasive surfaces that could damage them over time. 15. Periodically inspect the support system for signs of wear or corrosion. Replace any damaged or corroded components immediately. 16. Properly ground the fixture in accordance with the NEC. Grounding provides a path for fault current to flow back to the source, helping to prevent electrical shock. 17. Use flexible metal conduit or armored cable to connect the fixture to the electrical supply. This allows for some movement of the fixture without straining the wiring. 18. Ensure that the wiring connections are properly made and that all connections are tight. Loose connections can lead to arcing and potential fire hazards. 19. Use wire connectors that are listed for the size and type of wire being used. 20. Protect the wiring from physical damage by routing it through conduit or raceways. 21. Properly label all wiring connections for easy identification. 22. Use strain relief fittings to prevent the wiring from being pulled out of the fixture. 23. Ensure that the fixture is properly aligned and level. This will help to prevent uneven lighting and potential hazards. 24. Use a level to ensure that the fixture is installed straight and plumb. 25. Provide adequate clearance around the fixture for ventilation and maintenance. 26. Follow all safety precautions when working at heights. Use a ladder or scaffolding that is in good condition and properly secured. 27. Wear appropriate personal protective equipment, such as safety glasses and gloves. 28. Avoid working in wet or damp conditions. 29. Keep the work area clean and free from clutter. 30. Dispose of any waste materials properly. 31. If you are unsure about any aspect of the installation, consult with a qualified electrician or building inspector. 32. Document the installation, including the type of fixtures, the support methods used, and the date of installation. This documentation can be helpful for future maintenance and inspections. 33. Consider the energy efficiency of the fixtures being installed. Use energy-efficient fixtures, such as LED fixtures, to reduce energy consumption and save money. 34. Properly insulate the ceiling to prevent heat loss and reduce energy costs. 35. Use occupancy sensors to automatically turn off the lights when the space is not occupied. 36. Consider the lighting levels required for the space. Provide adequate lighting for the tasks being performed, but avoid overlighting the space. 37. Use dimming controls to adjust the lighting levels as needed. 38. Properly aim the fixtures to provide the desired lighting effect. 39. Avoid glare by using fixtures with proper shielding. 40. Consider the color rendering index, or CRI, of the fixtures. Use fixtures with a high CRI to provide accurate color rendition. 41. Maintain the fixtures regularly to ensure that they are operating properly. 42. Clean the fixtures periodically to remove dust and debris. 43. Replace any burned-out lamps promptly. 44. Inspect the wiring and connections regularly for signs of damage or corrosion. 45. Test the grounding system periodically to ensure that it is functioning properly. 46. Keep a record of all maintenance performed on the fixtures. 47. When replacing fixtures, consider upgrading to more energy-efficient models. 48. Dispose of old fixtures properly. Some fixtures may contain hazardous materials that require special handling. 49. Consult with a lighting designer to create a lighting plan that meets the specific needs of the space. 50. Consider the aesthetics of the fixtures. Choose fixtures that complement the overall design of the space. By following these best practices, you can ensure that lay-in fixtures are properly supported and safely installed, minimizing the risk of accidents and ensuring compliance with applicable codes and standards. Ignoring these guidelines can lead to serious consequences, including structural damage, electrical hazards, and potential injuries. Always prioritize safety and consult with qualified professionals when in doubt. The long-term reliability and safety of your electrical system depend on it.